Hi everyone, welcome to the Bioinformatics Coach channel. In today's video, I am going to show you how to trim Nanopore Reads using the tool Porechop. So for this tutorial, we are going to perform a basic adapter trim. So let's go to the Porechop documentation page to look at the example command. So there's a page, and I'll leave the link to this page in the description box. So when you are here, scroll down and you'll find some notes. Let's take a look at the table of contents. So let's start with the installation. So the installation you can install from source, you can build and run that installation. You can also use Conda to install. And I have tutorials that show how to install Porechop. So check the description box, you'll find links to those videos. All right, so use them to set up your PC. Now let's go to the quick usage example. So this section has the example command we use. So click it and you'll be sent to that section. So we are going to perform basic adapter trimming. So we will use a command like this. I'll add some options to it. So that's what we are going to do. For the example data, don't worry, I'll show you where to get one, so it's fine. Now let's open our terminal and then start the exercise. Okay, we are in the terminal now. So what I'll do is to first create a working directory and then I'll cd into it. So I'll say make the Nanopore and I'll cd into it. Now I'm going to get example data. So let's head to the ENA database. Let's head there. So this is the ENA database, the European Nucleotide Archive. So I'll leave the link to this page in the description box. So when you're here, come to the enter accession here, this side here, and then paste this accession ID. Yes. I have left this accession ID in the description box, so use that. So just copy and paste here and then click on view. So when you click on view, you'll be given access to the data. So there's the Oxford and Nanopore data, right? It's a Mycobacterium ostrans isolate. So we have that here. So that's what we are going to do. We are going to download this data here. And by the way, you can visit this page directly. So you don't need to search and then come here. So I'll leave the link to this page also in the description. So just use any of those links to get the data. So when you are here, scroll down this side and then just use your scroll bar to get to the right side. So this is the file we will use, right? There's a file. So what you have to do is to download. So to download, you can click to download, but because I'm on the terminal, I'll just use the download link. So I'll right click and then I'll copy the link. And then I'll move to the terminal to download it. So when I'm here, I'll use wget, but you can also use curl, but I prefer to use wget. So I'll type wget and I'll paste the download link there. And then I'll execute this command. So this will download the file for me. So let's wait for everything to get done for us. Okay, so the file has been downloaded. So do an ls and we're going to find it there. Now, this file here, you can see that it's a table, right? That means it has been compressed. So we have to uncompress it. So that means we have to process it so that we have just this FASTQ extension. All right. So we need to extract the content basically. So that's what I'll do. I'll uncompress it. So I'll say fz and I'll supply the file name like this. So let's execute this command. So it's been uncompressed. So now it's done. Let's clear the screen. Let's do an ls. We are going to find the file there. So there's the FASTQ file. Now the FASTQ file, you can also compress it again. All right, so you can do that to save space, but for this tutorial, we are going to keep it as it is because it's just a small file. So, but ideally, you should compress your FASTQ files to save space, right? So we have our file. So we will just proceed. So let's do this. Let's also organize our files better, all right? So I'll create a directory. I'll say make the raw reads. And then I'll move this FASTQ there. I'll say mv and I'll supply the name and I'll move to raw reads, right? So if I do an ls, I'll find the raw reads here. So ls into it, you'll find it there. So It's just a way to organize the file because we are going to trim. So that means we will generate another file. So we don't want to mix up all those files. All right, so now we are going to perform the adapter trimming. So I'll create another directory. So I'll say make the trim reads. All right, so this is going to be the output directory. Now we are going to call Porechop. So if you have installed Porechop, you can just type Porechop like this, and then you have something coming up. So once you see this, that means everything is fine. So we are going to use some of the options here. Let me just clear the screen and continue. Okay, so let's do an ls again. Let's ls into our raw reads. That's fine. So we can proceed. So now we have the directory which has the input files, and there's also a directory where we are going to save the output. So I'll start the trimming. So I'll call Porechop, and then I'll say -i, and I'll specify the raw reads /all minion. I need this file, so it's raw reads / I give this. Now I'll say -o to specify the outputs. So we will save it in the trim read / and we can give it another name here. So that one you have to give it a name. So ideally you should have a naming convention, especially if you are dealing with multiple samples or multiple files. But for this area, we are using just one file, so we'll give it a name that you want. So I will just say trimmed dot, let me say trimmed minion. Let me just use that one to grab it dot pascal.gz. Now, why am I using .gz? It's because I'm going to specify another option. So I'll say -- format. I'll say pascal.gz. Right, like this. Let me just minimize the text. Okay, so this becomes our final command. So the -- format is used to specify the output format. So with the output format, let's just look at this. I open one here. So with the output format, you can set it to auto, that's the default. We also have this. So it depends on what you want at the end of the day. But I'm using pascal.gz, so that is why I specify that here. Right? You can also add number of threads. So this is very important because it can speed up the process. All right. So if you're using a Linux cluster, an HPC system, you can specify the number of threads to use. All right. So let me even show you that one. I think that would be better. So I'll say -t. I'll use it as -t. Okay, let me just confirm here. -t, and I'll specify the thread. So I'll say 6. I'm using my normal laptop, so that's why I'm specifying 6. But if you have more CPUs, if you have more cores, you can increase it to speed up the process. So this becomes the final command for the basic adapter trimming. So let's execute this command. All right, so now Porechop is working. So it's now looking for known adapter set. So it will do everything. You also see the progress on the screen. Then you can proceed. So let's wait for everything to get done for us. Okay, the adapter trimming has been done. So you can look at the report here to see what has been done. Let's clear the screen and continue. So let's do an ls, and then you'll find the file here. So let's ls into the trim reads. You'll find it there. So this is the file. All right, the outputs. Okay, so these are the trim reads. All right. Now, since we are dealing with Nanopore data, ideally what we should have done first was to perform quality control. So you can use tools like Nanopore to do it. And then after trimming, you can also perform quality control and then compare the quality of the reads of the data of the raw and then the trimmed. And then you can decide which one you use for the downstream analysis. All right. So after getting your final reads, one of the things you can do is to filter the reads. So for example, you can filter and remove reads that are shorter than a particular threshold. You can also filter and remove reads that, for example, have an average quality of less than a particular threshold. You can use tools like FastSpeed to do that, and I've got a tutorial on that. Now, for this data, it is a Mycobacterium ostrans genome data. Right? So that means we are dealing with a bacteria data. And so one of the things you can do after getting your final reads is to perform genome assembly. You can use tools like Fly to do that. And I've covered some tutorials on this particular topic where I show how to assemble long reads. So check the description box, you'll find the links to those videos. You can also check the video right here to learn how to assemble long reads.